So in this video, I want to verify the identity cotangent A minus tangent A divided by cotangent A plus tangent A is equal to cosine of 2A. The rule of thumb is to start with the more complicated side. So I'm going to start with the left-hand side. You can imagine if we just wrote down cosine of 2A on the page and then said, okay, so I'm just staring at cosine of 2A. I want to turn it into cotangent A minus tangent A, blah, 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 blah. See, when you start with the simpler side, it feels next to impossible. Well, what the heck am I supposed to do with cosine of 2A? When you start with the more complicated side, then you can approach the problem as if you're trying to simplify with a specific answer in mind. So that's the idea here. So I'm going to write down the more complicated side, which is the left-hand side. Now I want to turn it into cosine of 2A. So I know there's three versions of cosine of 2A. It's got that cosine squared minus sine squared, or 1 minus 2 sine squared, blah, blah, blah. But they all involve sine and cosine. No tangent mentioned at all in the double angle formula for cosine. So that makes me think, okay, well, maybe I should start out by changing this to sines and cosines and see what happens. So that's the best way to start. Use the fact that cotangent is equal to cosine over sine minus tangent is equal to sine over cosine. Divided by cotangent, so again, cosine A over sine A. This time it's plus tangent, which is sine over cosine. And now, like I said a minute ago, approach this like we're trying to simplify. Let's say the instructions were to simplify, and we've looked in the back of the book, and the answer that we see in the back of the book is cosine of 2A. So we're just trying to show work that shows how we could get to that answer. So this is a mess. A good idea at this point is to clear these inner denominators. This is a complex fraction right now. If we want to clear these inner denominators, then we can multiply by, well, let's see, what do we want to multiply by? Definitely sine of A to clear this denominator. Definitely cosine of A to clear this denominator. And then sine of A, we already have that. Cosine of A, we already have that. So I'm going to multiply top and bottom by sine A cosine A. Multiply the bottom here by sine A cosine A. And I'm going to write that out with that sine A cosine A next to each term. Which is going to take me a minute. This is where it'd be nice to have a little music in the background. But I'm not going to sing or anything. Sine over cosine. This was our tangent. Divided by, okay, so a lot of work, but it's going to be so satisfying once we write this out and cancel. Plus sine A cosine A times sine over cosine, finally. Okay, so the sine of A will cancel here. The cosine of A will cancel here. Okay. This part where you're supposed to get a lot of satisfaction. I don't know if you did or not. But now we're left with cosine A times cosine of A. So I'll write that as cosine squared A minus sine A times sine A. So we'll write that as sine squared. When we simplify this denominator, we're left with cosine times cosine. So that's cosine squared plus sine times sine. So that's sine squared. Now, this is where it really helps to memorize the fundamental identities. Even if you're taking open note exams, which during these online semesters, many students are. But still, having the fundamental identities in your head, like the Pythagorean identities, helps because this should catch your eye. Cosine squared plus sine squared. It should jump out at you, and you remember, oh, hey, cosine squared plus sine squared is equal to 1 when you have the same angle inside here. So this denominator is just equal to 1. And I don't want to squeeze it on the board like I do sometimes, so I'll erase this. It's only going to take like one more line to finish this up. But so that gives us, so I'm not doing anything at this point with the numerator, but this denominator is equal to 1. And now, I mean, you can always keep one eye on where you want to end up. Oh, cosine of 2a? Hey, actually, this is one of those formulas for cosine of 2a. This numerator right here is equal to cosine of 2a. And so we're done here. We've shown that, okay, this is equal to cosine of 2a over 1, which is the right-hand side of that original equation. So we've shown step by step, using just algebra and fundamental identities, that this expression is equal to this one. At this point, you've shown every step of why that is true, which is the idea in these verify the identity problems.